Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of optimization. So as per the problem, a thin rigid pole needs to be carried horizontally around a corner joining two corridors which are 1 meter and 0.8 meter wide. Calculate the length of the longest pole that can be carried around the corner. So in this diagram, we are shown the two corridors. One of them is 0.8 meter wide, the other one is 1 meter wide, and the pole is this blue line here. As per the diagram, the pole is shown making an angle theta with the horizontal lines. One part of the pole has length x and other part of the pole has the length y. So as per this diagram, the length of the complete pole will be equal to x plus y. Now we have to find the length of the longest pole that can be carried around this corner. So we'll have to write the equation for length in terms of variable, and that will be theta. Because we can see in this diagram that both parts of the pole make an angle theta with the horizontal line. The shown triangles are right angle triangles, so we can use SOHCAHTOA to find the equation between theta and x and theta and y. So let's analyze the bottom triangle. In this triangle, the horizontal side length is 1 meter, the hypotenuse is x meters long, so we can use cos ratio to write an equation. The formula for cos is adjacent over hypotenuse. Now we can isolate x in this equation. We can cross multiply the x. Now we can isolate x by dividing both sides by cos theta. I get x equals 1 over cos theta. Now we can do the same analysis for the other triangle. In this triangle, vertical side length is 0.8 meters. The hypotenuse is y meters long. So we can use the sine ratio. The formula for sine is opposite over hypotenuse. Now we can isolate y in this equation by cross multiplying the y. Now we can divide both sides by sine theta. I get y equals 0.8 over sine theta. Next we can do the substitution for x and y in the length equation. So this is the equation for the length of the pole in terms of theta. Next we can find the derivative of this function to find the critical point. So for that we should change this equation to make it easier to find the derivative of the L function. We should move the cos and the sine terms to the numerator. So we get the exponent on the cos becomes negative because we are moving the term from the denominator to the numerator, and we can do the same for the sine term. Now we can find the derivative of this function using chain rule. So as per chain rule, we start with the derivative of the outer function. In the first term, cos theta to the power -1, the outer function is function with the exponent -1, and we'll have to use the power rule. So as per the power rule, we'll move the exponent to the front of the term, and we subtract 1 from it, times the derivative of the inner function. The inner function is cos theta, and the derivative of cos theta is minus sine theta, plus 0.8 is the coefficient of the term, so it will stay as it is. Now we'll have to use chain rule again. So we'll start with the derivative of the outer function. So we'll have to use the power rule. So we'll move the exponent to the front and subtract 1 from the exponent, times the derivative of the inner function. The inner function is sine theta and its derivative is cos theta. Now we can simplify this expression for the derivative of the length function and set the derivative equal to 0 to find the value of theta. Next, we can move cos theta to the power -2 to the denominator to make the exponent positive, and we can do the same for sine theta to the power -2. Minus sine theta will become positive sine theta. Next, we should move the fraction 0.8 cos theta over sine theta square to the left side, and that will make this fraction positive. Next, we can cross multiply the denominators. Cos theta times cos theta square will become cos theta cube. We can also write it as cos cube theta. And on the other side, we get sine theta times sine theta square, which will be equal to sine cube theta. Next, we can combine the sine and the cos terms by dividing both sides by cos cube theta. Next, we can apply cube root to both sides. On the right side, the cube root and the cube cancel each other out. So we get tan theta equals, we have to do cube root of 0.8, 0.9283, and next we can do the inverse of tan. I get 0.748 radian. So this is the value of theta at which the derivative of the length function is equal to 0. Now in order to find the longest pole, we should sub in this theta value in the length equation. Now we have to evaluate this expression. 1 divided by cos 0.748 is equal to 1.364, and now we have to do 0.8 divided by sine 0.748, which is equal to 1.176. Now we can add these numbers. I get 2.54, and the unit is meters. So this should be the longest pole that can be carried around this corner. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.